Right, well, here we are. This is installment number 14 on logarithms. This time we are given a problem in which we're supposed to solve for some variable z. This equation also has a logarithm in it, and it has a different little bit of information than we might have had in the past on some of our other problems. This one specifically has a square root sign. So we'll do a little bit of review, remembering what a square root actually is as we go through the problem. Our modus operandi is going to be similar to our previous problem in that we evaluate the logarithm first, just because it's a little bit of an unusual function in the context of normal algebraic manipulation, stuff like that. And then we go and plop it right back into the equation that we have. So we can invent a variable for that part of the equation. I like sticking with things like x, y, and z, and this one looks like a y would be very good because z's already taken. So if we just go and say y is equal to log to the base 10 of the square root of 10, then we can solve for y and put that back into the equation where it belongs. So we know by the definition of the logarithm that 10 to the power of y is equal to the square root of 10. Now the nice thing about this sort of a problem is if you remember what the definition of a square root is, it's incredibly easy. I can give you an example that, for example, the square root of 4. What times what is 4? We know 2 times 2 is 4, so 2 would be its square root. The square root of 25. 5 times 5 is 25. So the exact opposite, if we're doing the division, if we're going the other way around, saying the square root of something, it would not be putting something to the second power, but it would be putting something to the 1 over second power, to the half power. So by definition, in this case, 10 to the 1/2 is equal to the square root of 10. So y is equal to 1/2, or 0.5. I like keeping it in fraction form because it's easy. So now that we've gone and plopped and figured out y, we can put it right back into this equation here, and it will look something like this. Z times 1/2 is equal to 4. So in order to solve this one, that's pretty easy algebraic manipulation. You just take both sides of the equation, you multiply it by 2, and get z equals 4 times 2, z equals 8. So recapping what we've done. First, we solved what the logarithm to the base 10 of the square root of 10 was. Determined that it is 1/2. 10 to the 1/2 power is the square root of 10. Plugged it back into this equation and solved to determine that z is 8. Hope this helps, and I look forward to seeing you in the next installment. Have a nice rest of the day.